In today's lesson, we'll be looking at shapes of data distribution. We are going to describe and compare shapes of data distribution and then use that to choose appropriate measures of center and variation. We'll be looking at this through frequency tables, which are a statistical record of how often each value in a data set occurs, and we'll be looking at histograms, which are a data display where data is grouped into equal intervals and then plotted as bar graphs. Some key points from today's lesson. Data is skewed left if the tail of the graph extends to the left. This is the tail, the smaller portion, which means that most of the data is on the right. Data is symmetric if it's about even on both sides of the center. And data is skewed right if the tail of the graph extends to the right, meaning most of the data is on the left. All right, so example 1, describing the shape of a distribution. The frequency table shows the numbers of raffle tickets sold by students in your grade. Display the data in a histogram. Describe the shape of the distribution. Okay, so first we're going to make the axis of our histogram. And notice that the intervals go from 1 to 8. So our first interval is 1 to 8. Our second interval is 9 to 16. Our third interval is 17 to 24. So notice that second number in the interval is counting by 8. Each interval is even. Now this frequency, the number over here, that's going to tell us how many students sold that number of tickets. So I took that number of tickets and I put it on the x-axis, that is our independent variable. And then the frequency will be our y-axis. So I need to make sure my y-axis counts between 5 and 25. And now that I have both my axes labeled, I can start to plot the bars that represent each interval in the graph. All right, and now with my histogram graphed, I'm going to imagine a curve above the data. And it looks as though this data is distributed pretty evenly. The middle category is also the center of the data distribution. So we're going to say that this data is symmetric. It has a symmetric distribution. In example 2, we're going to look at how to choose appropriate measures of center. So if the data distribution is symmetric, then you can use the mean to describe the center and the standard deviation to describe the variation. We're going to focus more on describing the center for now. When the data distribution is skewed, the median, the middle number, is going to be a better description of where the center of that data is. All right, so example 2, choosing appropriate measures. A police officer measures the speeds in miles per hour of 30 motorists. The results are shown in the table. First, we're going to display the data in a histogram using 6 intervals beginning with 31 to 35. So I'm going to go ahead and fill in those axes. And once I completed the axis, I'm going to tally up how many go in each category. So from 31 to 35, there is only one motorist. So we're going to go ahead and make that bar. And then from 36 to 40, there were 3 motorists. So we're going to go ahead and fill in that bar. And then from 41 to 45, there were 5 motorists, so we're going to go ahead and fill in that bar. And then from 46 to 50, there were 6 motorists, we're going to go ahead and fill in that bar. And then from 51 to 55, there were 11 motorists, so fill in that bar. All right, and then last one, 56 to 60, that was 4 motorists. All right, so if we're looking at the center and variation of this data, if we imagine a bar above it, it looks like most of our data is going to fall between these 2 categories. Now the middle number is actually about right there, but most of our data is above the middle number. Most people were going between 51 and 55 miles per hour. So because the measure of center is more on the right, that means our data is skewed left, and that means the median is going to be the best representation of the data. All right, and the speed limit is 45 miles per hour, so how would you interpret these results? Well, people are supposed to be going this fast, and most people are going faster than that. So most people speed between 6 to 10 miles over the speed limit. All right, example 3, comparing data distributions. You'll notice that everything that I explain over video is typed out in the completed note sections on Canvas of our class site. All right, so we're comparing these two charts. One has the years of experience of professional football players, and the other has years of experience of company employees. So the years of experience of professional football players is skewed right, meaning most of the data is on the left, and most players have 3 to 8 years of experience. So most of the data is about there, which is on the left. The range is 20 years or 40, excluding the outlier. That one there is an outlier. All right, versus company employees, the years of experience of company employees is symmetric, meaning the mean is a good measure of center, and the average employee has between 9 and 14 years of experience. So most of the data is right there in the middle. The range is 23 years, and there are no outliers. For example 4, we're going to look at comparing data distribution specifically with box and whisker plots. If you need a refresher on how to create box and whisker plots, or you need some extra help on how they work, I would look back at the 11.2 notes. We went over how to create box and whisker plots there. All right, for part A, we're going to make a double box and whisker plot, which means there's just 2 boxes with whiskers on the same line, on the same number line, and then we'll describe the shape of each distribution. So the numbers to create the box and whisker plot are the minimum, the maximum, those are your 2 endpoints. The first quartile and the third quartile will tell you the ends of your box. The median is the middle number, and then mean and standard deviation are just some extra numbers here. All right, so here are my box and whisker plots, and it looks like the data for women is pretty symmetric. It's pretty even on both sides, and the median is 14. So you could count 14 as the average number of shoes that a woman owns. Men, it's skewed right, meaning the tail on the right is bigger. Most of the data is on the left. The median is 7. But mean might be a better measure of center, 8. So the average man owns 8 pairs of shoes. All right, part B asks us to compare the number of shoes owned by men to the number of pairs of shoes owned by women. In general, women own more shoes than men, and that is proven by this box and whisker plot. And part C, about how many women surveyed would you expect to own between 10 and 18 pairs of shoes? Well, our inner quartile falls between the numbers 12 and 17, meaning 10 and 18 actually surround that. So half of the data is between 12 and 17. 40 people were surveyed. So at least 20, at least half of 40, would own between 10 and 18 pairs of shoes. And that's it for our 11.3 notes today. Some summary questions for you. How do you create a histogram from a frequency table? Well, you set the data into intervals, make sure each interval is even, and then you plot it like you would a bar graph, but with intervals on the x-axis. When the distribution is skewed on a histogram, how do you determine which measure of center best describes the data? Well, if it's skewed, you're going to use the median, and if it's not skewed, you can use the mean. When comparing 2 histograms, why is it important that the intervals are the same? Well, if the intervals aren't the same, they're going to look different, and you're not going to be able to see where the measure of center is. It's not going to be as easy to compare. And then how can you use box and whisker plots to compare the distribution for 2 similar sets of data? Well, box and whisker plots lay out the median and the highest and lowest numbers quite nicely. When they're on the same line using a double box and whisker plot, then it's much easier to compare the two because the boxes are right next to each other.